This is a video from section 10.2. The directions say to find dx dt, dy dt, and dy dx. So we're going to start with example 1. Suppose I'm given x equals 2t to the third plus 3t, and y equals 4t minus 5t squared. So dx dt is going to be 2 times the derivative of t cubed, which is 3t squared, plus 3 times the derivative of t with respect to t, right? That's equal to 1. And so this is 6t squared plus 3. dy dt, well, that's equal to 4 times the derivative of t with respect to t, which is 1, minus 5 times the derivative of t squared with respect to t. That's equal to 2t. So this is 4 minus 10t. So therefore, dy dx is dy dt divided by dx dt. And that's going to be equal to 4 minus 10t. That's the numerator. And the denominator will be 6t squared plus 3. So therefore, dy dx, I'll just write it more formally here, is 4 minus 10t divided by 6t squared plus 3. And that's example 1. Example 2. Suppose x is t minus natural log of t, and y is t squared minus t to the negative 2. dx dt is the derivative of t with respect to t is 1. The derivative of natural log of t with respect to t is 1 over t. dy dt, that's 2t, right? The derivative of t squared with respect to t, right? Minus the derivative of t to the negative 2 is negative 2t to the negative 3. So that's just power rule, okay? And so that's 2t plus 2 over t to the third. And so dy dx is dy dt divided by dx dt. So that's 2t plus 2 over t to the third divided by 1 minus 1 over t. Now, what I want to do is I want to clear those fractions. The way to do that is I'm going to multiply the numerator and denominator by t to the third. It's just a fancy way to multiply by 1. Okay? Now, therefore, dy dx, so I'm going to get 2t times t to the third, so that's going to be 2t to the fourth, plus, now remember, when you multiply 2 over t to the third by t to the third, the denominators cancel, so you're left with 2. So it's 2t to the fourth plus 2. That's the numerator. The denominator, you're going to take t to the third times 1. That's going to give me t to the third. And then I'm going to subtract t to the third times 1 over t. That's going to give me t squared. So you should get this when we're all done. Example 3. suppose I had x equals te to the t and y equals t plus sine of t. So dx dt, by the product rule, I'm going to take the derivative of t with respect to t and get 1 and multiply by the second function, which is e to the t. And then I'm going to write t, and then I'm going to differentiate e to the t with respect to t, and that's just e to the t. Okay? And dy dt, the derivative of t with respect to t is 1. The derivative of sine t with respect to t is cosine of t. So therefore, dy dx is equal to dy dt divided by dx dt. And so that's 1 plus cosine t for the numerator. And for the denominator, I get e to the t plus te to the t. And so therefore, dy dx is 1 plus cosine t divided by e to the t plus te to the t. And that right there is example 3. We're going to do one more example for these set of directions. So suppose x is t plus sine of t squared plus 2, and y is tangent of t squared plus 2. So dx dt is 1 plus, now by the chain rule, okay, the derivative of the sine function is cosine, right? But I have to evaluate it at t squared plus 2. But then what you want to do is you want to multiply by the derivative of that argument. And the argument meaning t squared plus 2 with respect to t. So that's going to be 2t. So dx dt is 1 plus 2t cosine of t squared plus 2. Now, dy dt is the derivative of the tangent function is secant squared. So I get secant squared of t squared plus 2. But then I have to multiply by the chain rule by the derivative of t squared plus 2, which is equal to 2t. And so dy dx is dy dt divided by dx dt. And so we get 2t secant squared of t squared plus 2 divided by 1 plus 2t cosine of t squared plus 2. And so therefore, dy dx is 2t secant squared of t squared plus 2 divided by 1 plus 2t cosine of t squared plus 2. Now, suppose I ask you the following. Suppose I said find an equation of the tangent to the curve at the point corresponding to the given value of the parameter. Okay, so let's take a look at example 5. Suppose I had x equals t to the third plus 1, y equals t to the fourth plus t, and the parameter is t equals negative 1. Now, to find the equation of a tangent, really we're looking for a tangent line, right? So you need a slope, you need a point. Okay. Now, when you think of slope, we should be thinking about dy dx, right? And we just learned over here, right? dy dx is dy dt divided by dx dt. So let's come back and maybe we can take advantage of that. Now, dx dt is 3t squared. dy dt is 4t to the third plus 1. Okay? Now, dy dx is dy dt divided by dx dt. But this is 4t to the third plus 1 divided by 3t squared. Okay, so therefore, dy dx is 4t to the third plus 1 divided by 3t squared. Now, at t equal negative 1, dy dx is 4 times negative 1 to the third plus 1 divided by 3 times negative 1 squared, which is negative 3 divided by 3, which is negative 1. So therefore, we have slope negative 1. Now, at t equal negative 1, x is negative 1 to the third plus 1, which is 0, and y is negative 1 to the fourth plus negative 1, which is also 0. So therefore, my point is 0, 0. And when you have a slope of negative 1 at the point 0, 0, I could find my equation very quickly. So my equation is y equals negative x. And that's how you do example 5. Let's do one more for this video. Example 6. Suppose I had x equals square root of t and y equals t squared minus 2t, and my parameter is t equals 4. So dx dt is 1 over 2 square root of t. dy dt is 2t minus 2. So dy dx is dy dt divided by dx dt. So this is 2t minus 2 divided by 1 over 2 square root of t. But remember, when you divide by a fraction, you multiply by the reciprocal. So I could write this as 2 square root of t times 2t minus 2. Okay? So therefore, dy dx is 2 square root of t times 2t minus 2. At t equal 4, dy dx is 2 square root of 4 times 2 times 4 minus 2. So I just replaced t with 4. So this is 2 times 2 times 6, which is 24. So we have slope 24. At t equal to 4, x is the square root of 4, which is equal to 2, and y equals 4 squared minus 2 times 4, which is 16. So we have the point 216. Now, to find the equation of the line, remember, anytime you want to find the equation of a line, tangent line or otherwise, right? You need a slope, you need a point. Now, we could use what's called point slope form. Y minus y1 is m times x minus x1. Now remember, m stands for slope, and we have to look back. We have a slope of 24. And this is, x1 is 2, and y1 is 16, right? So we get y minus 16 is 24 times x minus 2. And we just want to solve for y. Y minus 16 is 24x minus 48. And so y is 24x minus 32. And that's going to conclude this video for section 10.2. We did 2 examples of finding the equation of a tangent line, and we did 4 examples of finding dy dx, dx dt, and dy dt. So, okay, thank you.